iedereen bij de tweede Dynaflow Lecture van dit jaar. We hebben vandaag als spreker Jan van Houwenhove, van de directeur van Cryonorm. Hij gaat ons een lezing geven over zijn systemen waar ze zich op specialiseren. Klein tot middelgrote energiesystemen. Aan de hand van een case en hij zal de nadruk daarbij leggen over wat technische aspecten die daarbij komen kijken bij dergelijke systemen.
Now, good evening, ladies and gentlemen, or lady and gentlemen. Yes, this evening I'll elaborate a little bit about the company I'm responsible for, and then as Niels just mentioned, very specifically about some of the projects that we already have done, but very specifically. But then we will come to some details with regards to this specific project. But before we come to that, I'll give you some outline of how this project fits into how we see the world of LNG, or the world of small and mid-scale LNG. Okay, so for today we'll do this. Now this is how we see the world of LNG, and it starts with gas basically, and it ends with gas. So it starts with natural gas in gaseous form, which is then extracted coming from pipeline or from a biogas plant or from the flare. And here in the end, it is actually also consumed or utilized in gaseous form. Right? So why not put a direct pipeline from there to there? Is because, of course, on a worldwide basis, we all know that the amount of liquid that is used in certain areas is not specifically there where the LNG, the natural gas, is found. So one way of bringing it to the customers from production side to the customer is by liquefying it. Now there's another reason for that as well, because for certain applications it is just simply impossible, of course, that you bring with pipeline gas, your gas to your application. The example is very simple. The maritime world. If you're looking at a ship, if you want to fuel a ship, or if you want to use LNG or natural gas as fuel for a ship, it's impossible to put pipelines in there, of course. So I mean, then you are forced to use it in liquid form in order to get the natural gas on board. So from this moment on, from the moment that it actually gets into the liquid form, all the way down to the point where it is actually used, this is the area where Cryonorm is actually situated. So that goes from liquefaction systems, so that's what we do as well. I'll give you some examples later on. We do have, let's say, the possibilities of making LNG bunkering systems on ships, on which we are actually currently working on a couple of them as well. Now this is the one that we will talk about today, which is LNG Bunkering Station shore to ship, LCNG and LNG fueling stations for trucks, or regasification systems for industry. And then over here as well, very specifically, and that is, we have a couple of projects which we already executed until, let's say, this year and last year, which are then very specifically the LNG fueling systems which are actually on board of a ship. Okay, so this is how we are seeing this, this supply chain. These are the 4 companies that are in our consortium. Our location in Alphen aan den Rijn. Now, projects, or Cryonorm projects, is doing the liquefaction. I'm giving you, that's one, this is the one that I just pointed out. And to give you an idea, this is a greenfield plant that we actually have built together with the company Indox in Spain. It's a greenfield, so I mean this is basically gas is coming out of the ocean in Ecuador. Since Ecuador is a very hilly place, the government of Ecuador has decided basically that they were going to bring the natural gas inland by using trucks and bringing it from, let's say, the shore side, or where this location is, to the inland by using the trucks. So basically what we have done is we have built the complete site, or we have helped building the complete site basically. The engineering was done by our company. Procurement was done most of it by our company as well. And then let's say the installation was done with local help, of course. Civil work was done by local people, and then the process engineering for sure was completely done by Cryonorm projects. And that's one of the key differentiations that Cryonorm has, the process engineering part when it comes down to cryogenic processes. And in this specific case, it is an LNG liquefaction plant, and we are using the liquid nitrogen cycle loop in order to manufacture up to 200 metric tons of LNG per day. Therefore, we have built in, of course, the necessary LNG pipelines together with the storage capacity, and then also the truck filling facility for the trucks to be moved inland. So this facility came in on stream at the beginning of last year and has been running smoothly. Actually, it's doing 220 tons per day as we speak. A picture of the installation in Ecuador. Actually, it was with joy, well, a joy within brackets, let's say, that we have found out that a similar facility is now let's say, signed in Bolivia, and we will also be doing an identical plant in Bolivia. Cryonorm themselves, we are into vaporization systems and heat exchangers. Now, a couple of examples then. There's aluminum heat exchangers, water bath heat exchangers, or electrical heat exchangers, to actually come from the liquid phase back into the gaseous phase. Now, and then Cryonorm systems themselves, a couple of pictures to show. Cryonorm systems, as we said, we are doing this part of the supply chain. One of the realizations that we did is with Simon Loos in Zaandam. This is a privately owned LNG filling station. They have 20 and very soon 40 of these Mercedes Actros trucks with LNG fueling system on board. So this is a gas engine basically. LNG is stored into 2 tanks on both sides of this truck. This is something that we did not supply, but we did supply a complete filling station, which is in this case a 20-foot container, because there was no permit to build a permanent installation at that site. And then we have actually engineered and constructed also this small privately owned filling station in order to make sure that LNG is transferred from that part to that part. So they're also from Greenfield. The next one up is a land-based installation. Again, the same situation. A certain boiler room in this case is in need of, in this case I believe it was 1,000 normal cubic meter per hour natural gas. That was the request. And then they have asked us to, let's say, engineer and then also construct the complete system. This was for a customer in Norway. We were, of course, we asked them on the amount of deliveries that they wanted to do on a weekly, monthly, yearly basis in order to fill this tank, and their yearly consumption as well, of course. And then it was a question of sizing it up accordingly, making sure that vaporization was big enough in order to make sure that the complete system was operational towards their boiler. Now, the reason why it is done like this is because this is what we call an off-grid customer. So most of the customers over here in the Netherlands, which is on the contrary in Norway, we all have pipelines. I mean, if a boiler room from any given industrial estate over here, they are all connected by the pipeline. It's very easy for them to use natural gas. Now in Norway that is not the case because of the size of the country and the geographical parameters of that country. They have decided there that they will move LNG from certain points on their fjords, land inwards towards the industry. And they were actually, the boiler room was until that moment in time, it was propane that they were using, and they exchanged that to methane-based LNG, of course. Now the next one is what we have done as well is, well, let's say the famous, because it's becoming a famous ship. This is the very, very first inland ship which is actually fueled by natural gas. It's a dual fuel ship. That means that inside here in the back there's a Caterpillar engine dual fuel, which is capable of burning diesel or gasoline, or a mixture of gasoline and natural gas. It's an 85-15% mixture that they need to have in order to fuel the engine. The ship is used in the Rotterdam harbor because this ship is actually a bunker ship, but it's a gasoline bunker ship. So it brings basically the petrol from the Shell the Shell, let's say, site to the different ships that need gasoline, MFO, MDO in the Rotterdam harbor. But the fueling system, which you see here, was basically engineered and designed by Cryonorm Systems, and also installed and started up by Cryonorm Systems on the ship. That was done November last year, and the anecdote there goes, the owner of the ship is Mr. Gerard Deen, who was the harborman or the havenman van Rotterdam last year. And this guy came to us about 2.5 years ago, and he said to me, look, there's no regulations on how to use LNG on an inland ship. There's no availability of LNG in Rotterdam at that moment in time. There's no procedure on how to bunker LNG. There's nobody that can actually bring me LNG at that moment in time, and still I want a ship that is fueled by LNG. Just make it happen. It was as simple as that, and then we said, okay, look, it's going to cost you 5 ton, zoals jullie zeggen, more or less. And he said, like, okay, let's go. And then we had to find out for ourselves, really pioneering, on how to overcome all these hurdles. Because we found out during engineering phase that there were, let's say, not a lot of rules and regulations which were in place. But still, by doing and by engineering it, we had to overcome all these hurdles in order to convince a lot of people from the authorities, from the safety, from the Commission of the Rhine, and everybody, in order to make sure that this was going to happen. So we were really in the forefront to convince all the relevant people, so that Mr. Deen, of course, had a safe system on board and a system that he could have an insurance for, because it was all about getting insurance and getting legal justification to put this system on board. Now, it took us 3 years, or actually 2.5 years to get everything done, but in the end, November last year, this ship came in, not November last year, November 2011, this ship came into the, let's say, a bottle of champagne was thrown against it, and on he went. Now, so after 14 months, 15 months of operation, this ship has now done according to the owner of the ship, and that's one of the big drivers of this industry at this moment in time. He says that his operational cost went down by 28% compared to the same period of time if he would have been fueled with diesel only. So this gives an opportunity. This gives an opportunity, as far as I'm concerned, to the inland shipping world of this part of the world to have their profitability of their ship going up dramatically. And we all know that inland shipping at this moment in time, they are in a very bad shape. And so this gives them an opportunity, or this gives them an opportunity in order to get this thing moving. Now, this owner was of course very clever, because he knew that certain subsidies was going to be handed out in order to get this thing on his ship, and he did receive, of course, a certain amount of subsidies in order to install this. But in a normal operation at this moment now, without subsidies, the payback period of putting or exchanging a diesel with a natural gas system is between 3 and 5, 6 years, let's say, depending upon the amount of hours that you do with your ship. An even bigger one at this moment in time, as far as we're concerned, is this is the very, very first monofuel ship. So this is a ship which is where LNG is the only fuel on board. That's why we had to make the system completely redundant. It's monofuel and it's gas electric, meaning that with Argonon, the engine, it has a direct link with the propeller. In this case, the engine is electrical, so there are electrical pods, as they call it, underneath the ship, and they are driven by generators, electrical generators, and these generators are gas generators, and are of course are getting the natural gas from the system that we have installed. What is very important in this whole thing is, of course, this little shell that is on this here, this little red and yellow thingy, which we were not aware of at the moment that this ship was signed. We were not aware that actually this company was going to be involved there. In the end, they said, okay, look, we are going to charter this vessel, these two vessels, and I can tell you, when it comes down to making an engineering project for a company called Peter Shipyards under the name of Interstream Barging, is a whole different ball game than making an engineering project which involves these people. Because the level of let's say, procedures and the level of paper that you have to crawl through is going from this to something like this. Now, we were in luck in the way that our project was already, let's say, very well advanced into the project before they actually could fundamentally change something in the way that we were doing things. Luckily, I would say, because otherwise this ship would have never been in operation as we speak. But that went into operation 1 month ago, and the sister ship of this one is going into operation within 2 weeks. So what Cryonorm does on this vessel basically is the inlet of the gaseous natural gas into the generator. This is our interface, and the bunkering point on the side of the ship, on both sides, port side and starboard. Those both sides, basically, that is all our other interface. So everything which is sitting between the truck, which is normally coming on the quay here to fill these two trucks, from that point onwards, all the way to the connection to the generator, is the engineering part and the executing part that we have done on this vessel. Okay, next one is the Anthony Vede, which is extremely similar to the one I just explained, and this is the very last one that we have signed about 3 weeks ago. But very similar again to the one I just explained. Now, the case I wanted to talk to you about is rather special in a way that it is a unique project at this moment in time. Unique in a way in sizing. Until now, there is one LNG bunkering station in Norway for a very small ferry boat. This one here is for a ferry boat which is going from Norway to Denmark and back. It's a land to or a shore to ship bunkering process, as you might imagine, and that is on the contrary to the Stockholm project. There is a project going on, or actually finished in Stockholm, where they have decided to do a ship-to-ship bunkering system, which is similar to this one, but then everything, of course, is happening from let's say, a bunker ship towards the ferry boat. Okay. So what is already existing on site over there is, as you can see, and I will go back one. Over here is so the pipe, the gaseous natural gas is coming on land. This is a liquefaction plant built by Linde, 250 ton a day. And this is a 20 million liter LNG flat bottom tank, atmospheric tank. Now it is from this tank basically that we will have to put our installation all the way down to this place right here. And so they have asked us to bring LNG from point A to point B in a certain way, with a certain flow and with a certain pressure, but I'll come to those details a little bit later. So what is on site is this. They already have a filling station for trucks and an LNG bunkering station ship to ship. So they are filling already ships with LNG for these ships then to move on to their customers. Now they already make a small amount of regasification there. This is mainly for a backup system, and this is the part that we are actually going to add to this facility. Okay, so this is the. So these people came to us and they said to us, again the same story as we heard before. Basically, this is new adventure. It is pioneering that you will be doing. There are no rules and regulations which are actually including the whole process of bunkering. But you will have a certain amount of, let's say, processes that you have to follow and EN norms that you will have to follow in order to come to this system. And so your engineering will have to, again, figure out, let's say, calculate, design and pioneer a system which is actually making sure that there is a safe way of bringing 450 cubic meters per hour LNG over 630 meters down here in order to overcome the 5.5 bar pressure into the tanks of the ship. So that was the task that we had in front of us. Now that was a task given to us by Scangas in January of this year. And the actual delivery date of this system is foreseen for 15th of January, let us say Q1 for next year. Okay, so this is the location. Since it was an existing plant for us, one of the items that we have to find out, of course, was to make a detailed plot plan and measurement of how we would actually fit the whole system in there. Now the system is going to be is designed, and I'll come to details a little bit later, but it's designed so that the bunkering time of this ship here is not longer than the loading or unloading and loading of ships and cars, trucks and passengers. So from the moment that this ship comes in and it docks, and at the end here, it brings down the back part of the ship, and the trucks are starting to be unloaded. At that moment in time, we need to start bunkering. It is foreseen in 90 minutes that operation is done, and in that moment in time, we have to make sure that the tanks are filled again with LNG, so that the ship can move on. The tanks inside this ship are manufactured, are engineered basically, and are manufactured by a Turkish company, and the engines in here are the Rolls-Royce company, Rolls-Royce. The two tanks inside here are 2 times 300 cubic meters, and they believe that to make the Norwegian, Danish in and out, they will need around 250 cubic meter of LNG. So we need to basically fuel 250 cubic meter of LNG within 90 minutes. And that was a big challenge as well, because I mean, for us, this was important, of course, that the whole system was designed in order to make sure that this timing was met. Now, at the same time, and that is an operational challenge, definitely when it comes down to safety. At the same time, as I mentioned, cars and trucks will come on board. That means that passengers will come on board as well. And there is a little passenger staircase between the building and the ship as well, which is very close to this bunkering point here, where passengers will cross as well. So we have a big challenge to overcome in order to make sure that that can be done in a safe way. Now, one thing that we had to make sure is, of course, with regards to this timing, very soon inside the engineering process, we decided that we were going to have permanently LNG in the line. So the 630 meters of pipe, which are actually going to be installed, will be cold 24 on 24, 7 days out of 7. Making sure that the timing for bunkering is as limited as possible. So there is only one part, which is the loading arm, which we are going to install here. That part is going to be cooled down at the moment that the ship is actually anchored. So that is, let's say, we will have to wait, or we will need the necessary time to cool that thing down in order to start the bunkering process. But the rest is going to be, let's say, inside minus 162 or between minus 162 and minus 152 constantly. So that means that, let's say, in order to do so, we have made the choice of installing vacuum insulated line over, let's say, 630 meters long. So from here, an 8-inch line will be vacuum insulated all the way down to the ship. Then we came to, of course, the process engineering. Came to the fact, of course, how are we going to handle emergency shutdown, ESD problems that we needed to overcome. And one of the biggest issues that we had to overcome was the fact that if that ship is actually drifting away from the quay, then you need to have what we call a breakaway coupling, which is not a pneumatic, but it's an emergency release coupling that they call it. In order to make sure, of course, that your loading arm is actually physically separated from your ship. Now that creates an instant stop here, and so therefore, of course, we had to make sure that our complete system, with the pump sitting here, pushing 450 cubic meter per hour at 8 bar or even higher, all the way here. Here there's a certain shut-off. How do you design this thing here in order to make sure that the liquid hammer effect is, of course, solved? So therefore, let's say we had the help from Dynaflow to help us out in order to make sure that this was done in the proper way. And so we have designed our system in order to do so. The next thing that we had to make sure was that the fiscal transfer was done in a proper way. Measuring LNG is very, very, very difficult. And definitely measuring a flow of energy, LNG is very, very difficult. There's only actually, at this moment in time, one company in the world, and that's Emerson, that is actually can provide us with an MID approved fiscal system in order for us to make sure that you can transfer an amount of LNG from A to B and actually also have a delivery note on which you can base your invoice on, which was also, of course, very important. You need to be able to show to your customer, or to the final customer, which is the ship, how much transfer there was from A to B. Now, in order to overcome this, we have used the people from Emerson to help us out there. But most of the time, the Emerson people say, okay, your measurement point has to be as close as possible to the final customer, which is only logical, of course. Now, the people from Scanga said, no, this is not going to happen, because here we need to create a system in which you can have 0 valves. That is your target. You have to just tell us how many valves you'll need, but your target is 0. Because basically here, well, I told you that there were passengers going to go from the building into the ship. Over here there are a lot of passengers, and they were going to create here a zone for transfer of LNG, and we have to make sure that that system there is as simple as possible, so that we have the perception of safety as high as possible. Because it's already going to be, let's say, complicated enough to see a loading arm there with, let's say, LNG going through, which means that on the outside of the loading arm it's going to be completely frosted, and you will see foam, and you will see, let's say, vapor, of course, water vapor, which is identified as gas, which is potentially dangerous then. So we want to avoid you having here valves and systems in there as much as possible. So we had to figure out on how it was possible for us to put the flow metering system here. But then, of course, Emerson said, I mean, I can never MID approve this. So it was between us and Emerson to figure out a way on how to engineer this in a proper way, and we succeeded in doing that as well. One of the biggest challenges that we had as well was the loading arm itself. the loading arm people are, let's say, there's a big French group, FMC, and a big German group, SVT. So we chose in the end to go with SVT. But these people have, let's say, their reference list, and their experience is mainly with gas carriers, with the huge LNG gas carriers, on which they come to Gate, they come to Zeebrugge. And there, of course, they have these huge big loading arms with a lot of, I call it metal, and a lot of, let's say, weight, huge systems. But that's what their experience of. And so these guys basically said to us, oh, we have in an experimental phase, we have a very refined loading arm in order to feed you with, or let's say in order to install there an ergonomically and visually accepted solution, because that was very important for the customer as well. And so we will have to try this. And that was also a design which needed some more engineering, which was done by SVT themselves. But in the end, they succeeded in convincing the customer, because they had to convince Scangas, in order to get this organized. So these were, let's say, in short, the main issues that we had to resolve, not all of them, of course. This is the ship. You will not see the LNG tanks on the outside here, because this is one of the very first ships where LNG is actually, the LNG tanks are actually sitting under deck. Okay, so the rules and regulations that you have to follow in order to install an LNG bunkering system. These were, let's say, presently, and these are the literally words from Scangas. There are no practical guidelines on an acceptable design for bunkering operation of LNG vessels with passengers on board. However, LNG bunkering exists and is framed by the following regulations and guidelines. So these guidelines were, let's say, used by us. And we were asked by Scangas to use these. Now, last week I was in Norway, in Oslo, and there was a presentation there of DNV, one of the classification agencies. And they proudly presented to all of us last week this document, which says Guidelines for Systems and Installations for Supply of LNG as Fuel on Ships. Draft copy of the 6th of June of 2013. Right? They proudly announced that to us in the middle of our design phase for this existing thing. So basically, the rule that I have, the guidelines that I have here are exactly the opposite of what is said here. Now, presently, there are practical guidelines at this moment in time. Of course, it's still a draft copy, but it will have to be. It's a copy. It's let's say DNV informed me that it's highly likely that these guidelines will be used for the future of LNG bunkering systems. So now we have a challenge, of course, in order to see how these guidelines will fit with this. They do, because I mean there are a lot of reference with that. But of course, since we were pioneering our way through all these individual EN norms, now we have to figure out if it still fits what we have here, because I'm talking 4th of June, we are now 13th of June, that's 9 days ago. I mean, engineers are working this out in order to make sure that that this is actually going to work. Okay. So most of this I already have told you. So there will be 2 ferries. Fiscal Transfer, we talked about that. 8-inch bunkering line, it's coming from a 12-inch. Booster pump is going to booster LNG 450 cubic meter per hour max flow, transferred to a loading arm. Additional bunker line is the vacuum insulated piping, we talked as well. So the frequency of the ferry is every second day, so that means that every day there is a ferry under normal conditions. 90 minutes, and the bunker volume is about 220 cubic meters. One thing I'm not telling here is that the engine of the ship is a Rolls-Royce engine, and typically these engines, not typically, but this very specific engine has a 4.7 bar intake of gas. That means that the LNG tanks on board of that ship are typically 5.7 bar, so they are, let's say, set at 5.7 bar. That means that they are also, let's say, saturated at 5.7 bar, because during the whole running of that ship from Norway to Denmark, the LNG will be saturated at that 5.7 bar. Now 5.7 bar, that means that the LNG is actually warm. Now I don't know if this is something of my own. So the LNG, I'll come back to this. The LNG will be sitting at 5.7 bar, so that means that the LNG itself is actually sitting at minus 135 degrees. And so we have to fill in the LNG into that tank. So that means that in order to, of course, transfer an amount of LNG from point A to point B, we have to overcome that pressure. Now, overcoming that pressure is going to happen by using our pump, of course, which we have designed to overcome and to be able to give at the loading arm 8 bar, so that we will always be able to overcome that pressure. But also what we will do in order to facilitate the whole process, and also to make sure, and that was also a guideline from SCAMGAS, that there is no return gas, or there's not a single drop of methane returning to the site. We had to make sure, of course, that we have our system designed in a way that was done. And the way that you do that is basically, you have your vapor sitting at 5.7 bar, and you have your liquid sitting at 5.7 bar. The ship is coming in, and you basically what you start doing is you attach your loading arm, and then you first start filling on the top of the tank with LNG, which is, let's say, 1.5 bar, because it's coming out of an atmospheric tank, but is then by the pump is actually brought up to 8 bar, but you still have your saturation of your LNG sitting at 1.5 bar. So by topping up, or by bringing the LNG on top of the tank, and you spray basically the cold LNG into this hot LNG, which is actually sitting on the top of the tank, you bring down your pressure. And by doing that, you can actually make sure that your safety relief valve setting is not attained while you are doing the filling of the tank, either on top or on bottom. And that is the way that, let's say, the system will be operating. We also had to make sure that the engines can continue on running, and therefore we will only fill one tank at the time. So basically, if one tank is finished with filling, we will start filling the other tank. So that alternative, also the ship's engines will be able to use gas either coming from one tank or from the other tank. Okay. Okay. Concept is based on parties' experience, of course, and the key requirements, which were already mentioned: short bunkering time, and requirement of parallel activities such as cargo handling. In this case, sorry to say, passengers. It's not cargo, of course, but I mean it's kind of let's say in the rules it's kind of similar. At idle conditions, bunker line will be filled with LNG. So also there we had to make sure, of course, that if your system is sitting idle for 24 hours. Even in a vacuum insulated line where insulation is, of course, extremely good, you will still have heat inleak through radiation, convection, and conduction. And so there's going to be a temperature increase of that line, of the LNG in that line. And so we had to overcome that as well in order to make sure that this line will not basically burst. We have a gas return line for that. But that gas return line is, as I said, only used for the LNG which is actually coming from the site itself. So the LNG coming from the ship is never going to be returned to shore because of, let's say, interactions that they didn't want. We mentioned, or I mentioned this as well, which is the famous fast valve operation, which is the liquid hammer effect, of course, that we have to take into account. Now the fiscal metering is also you saw this. Now this is an example of a cryogenic pump. This cryogenic pump is in a sump, basically, and a sump is also, so it's a pump which is submerged into LNG at all time. At the same time, this sump will also be insulated as much as possible. In this case, it is going to be insulated by polyurethane. The LNG pump is continuously sitting in the liquid. It is a booster pump, so it gets 4 bar from a main pump, which is already sitting on site, and it's actually then unloading at between 8 and 13 bar, depending upon the pressure needed at the end of the line. But also here, in order to make sure, of course, that there's a fast delivery time, this thing is constantly sitting in the LNG, in order to make sure that, let's say, from the moment that the attachment is done at the loading arm, pumping can start immediately. Part of the P&ID that we have here, and this part is actually the part which is linked to the flow meter. It's a double flow meter, basically. We had to make this one redundant because at certain moments in time, calibration will have to be made, and then one unit will be used at all time, and the other unit will be taken out for calibration, and then this unit will come back. This unit will calibrate with this unit. That is the way that we saw. So I mean, in order to make sure that LNG bunkering can always happen, because the measure or the calibration of this unit can take more than 24 hours in some cases, and of course we have to bunker every 24 hours. Principle of certified marine bunkering measurement solution. So micromotion Emerson is the one that is helping us, and this is the most important part here, MID approval, meaning that it is fiscally correct to transfer from point A to point B, and you have in your hand an approved fiscal approved document which says this is the amount that I gave from point A to point B, which was very important for our customer. Now, vacuum insulated line, I mean, I'm sure that you are all aware of that. You either use the compensators on the outside or on the inside. In our case, the compensators are sitting on the inner vessel, on the inner pipe. In this case, it's not. It's a MLE, so it's a multi-layer insulation that is used, of course, in order to make sure that you are protecting this inner pipe at minus 162 degrees as much as possible from heat in leak. The sections, they are 12 meters long. They are pre-manufactured here in the Netherlands with a company called Demaco, which are specialized in this kind of pipes. And then they will be transferred to Norway, where Demaco will do the installation on site of 613 meters. And then part of this piping arrangement will be sitting into a culvert, which is sitting below ground. Another challenge that we have to take into consideration. Okay. Issues left. In this world of small and mid-scale LNG systems, it is actually, as you heard the word pioneering at some occasions this evening, I mean, that is truly what it is at this moment in time, and that means also that, as always, I would say the official instances are late in providing us with the standards. And therefore, certain standards are not there yet. And so, let's say, whatever we can find, we use. For instance, on this one here, the physical connection. So basically, bunkering is done on a worldwide basis. That's the idea. Ships can go everywhere. You have to make sure, of course, that your part which is sitting on the shore or at your bunker boat is connecting with the part that is sitting on the ship itself. And that is, let's say, we believe that an ISO standardization will be needed on a worldwide basis in order to overcome this, because most of the time, one of the big issues that we have is that normal flanched connections, which is the way in some cases that is done at this moment in time, it is done, are, as far as we're concerned, not safe enough and not reliable enough for leakages in order to get that used on a let's say bigger scale. We are actually using at very specialized LNG dry connections, as we call it, which are existing already at this moment in time, but which are pretty expensive, but still, in order to make sure that these are standardized throughout the world. And basically Cryonorm Systems is in that work group on that level in order to make sure that this type of standardization can be helped. Now, I'm only giving one example here, but certain other standardizations are needed in order to get this thing moving forward. Okay, and then more projects, of course. I mean, that's what we all want, and that's, I think, that what is going to happen as well. Now, conclusion. The LNG bunkering system in the market, I mean, as far as we are concerned, with the experience that we are seeing now, and let's say the amount of time that we have spent into the project and the time that we need to still spend in order to make it happen, We believe that, I mean, we don't believe, we know that it is possible. So there were a lot of hurdles and challenges, but we can overcome them all in order to make sure that LNG bunkering is available. This one is an extremely important one, but the economical level I just touched very briefly with the 28% on argon. Now the environmental drivers, we all know about that one. We all know that natural gas, of course, what we see was considered as the clean fuel. So when it comes down to fine dust, smog, it's 100% down, SOx 100% down, NOx 80% down, and CO2 emission also 20% down over conventional bunkering fuels, which are oil-based fuels. And very specifically for cities like this, Rotterdam, where there are a lot of ships coming in, and there's a lot of ships basically that are using their engines inside the harbor, the amount of NOx released from any, let's say, industry, ships or transport at this moment in time, the shipping industry in this city is by far the biggest NOx polluter of all the pollutions that we have at this moment in time. So moving to cleaner fuels, of which LNG is one of them, is what we consider as the way forward. Classification is very important, people. In the marine, I don't know if people are from marine environment here, but in the marine sector, as I learned, classification agencies are extremely important agencies, because classification agencies are chosen at the moment that the ship is going to be ordered. So you order a ship and you say immediately, okay, classification is going to be DNV, Germanische Lloyds, Bureau Veritas. Right? Those are the four majors. There are a couple of others, but that is decided at the very beginning. And then basically every single bolt and nut that is used on that ship needs to have then the classification of that agency. So if I'm actually installing a pump on a ship and it is DNV approved, then I will have to make sure that the engineering, or let's say the classification agencies of a supplier of that pump is providing me the pump with the DNV approval with it, because otherwise I will never be able to install that on the ship, which is very much different than land-based installations as I have now with Rizavika. There it is DNV approved, but still if I come in with a pump which is CE marked by Lloyds, and then the flow meter which is done by Bureau Veritas, I can still make a DNV approve the whole system, because they will have to accept the others being classified by another agency. Marine, there's no way, that's out of the question. So most legal frameworks are in place, but not all of them, of course. And then that's extremely important, this one here on top. We do believe that that is the LNG shipping market at this moment in time has an extremely high safety record. There has been, until now, no major accidents with LNG transfers so far. On a daily basis, we are talking about between, let's say in Europe, between 20 and 30,000 LNG transfers on a daily basis. And so no major issues or no major incidents and accidents so far. But by, let's say, growing the industry of small and mid-scale, of course, we have to make sure that all of us within that industry are making sure that the installations that we are putting out there are of course done in good workmanship and within, let's say, the safety rules that we are putting ourselves onto. Bunkering procedure, international business, international standards again, and then important that all actors, and that is, let's say, the more I go and see customers, the more I see also that let's say a certain amount of training is needed. So what I give next to these type of presentations, I also give workshops on LNG, basic workshops on LNG, where I actually explain thermodynamics of LNG and physical parameters of LNG. And in that workshop, I also bring a liquid which is very close to LNG, and that's liquid nitrogen. Now I bring that along with me so that people are aware of what LNG is all about when it comes down to the temperature. And I do see that when I start talking about thermodynamics and about saturation, that let's say a lot of the customers, and definitely in inland shipping, it's extremely far to their comfort zone. And therefore, if let's say inland shipping is starting with LNG bunkering, is starting with more ships into there, I mean it is extremely important. That let's say the amount of training, basic cryogenic training, but also basic safety training is given to the relevant people in order to make sure that this thing here is of course done in the correct way. So this brings me to the end of my presentation. If you have any questions in whatever language you want, I mean I'll be glad. I'll try to answer them.